Hello student, today we are going to discuss about the topics periodic table, periodicity of the properties of the element. Till recent, more than 118 elements have been discovered. Each element has its characteristic physical and chemical properties, so it is quite impossible or difficult to remember the properties of this element. It is for this reason that efforts were made to classify the elements on the basis of a common property, so as to make a systematic study of the elements. So, first the law is law of triad, and it is proposed by Johann Dobereiner in 1817. So, the first law is law of triads. It is proposed by Johann Dobereiner in 1817, and the law explains that when elements are arranged in order of increasing atomic masses, groups of three elements are obtained which have similar chemical properties. The atomic weight of the middle elements was found to be an arithmetic mean of the atomic weight of the other two. There are three examples. The first group of element is lithium, sodium and potassium form a triad. The atomic weight of sodium is the average of potassium and lithium, that is 7 plus 39 by 2, that is 46 by 2 is 23. And the second group of elements are calcium, strontium and barium forms a triad. Atomic weight of strontium, that is middle element, is the average atomic weight of calcium and barium, that is 40 plus 137 by 2, that is 88.5. And the last example is chlorine, bromine, iodine. These three elements also form a triad. Atomic weight of bromine is the average of chlorine and iodine, and it is 81.25. But this law has some limitation. The first is all the then known element could not form triads. The law failed in case of very low mass or for very high masses. As the techniques for measuring atomic masses improved significantly, the law was unable to remain valid. After the law of triads, there is another law, that is law of octaves, proposed by Newland in 1864, and the law is when the elements are arranged in increasing order of their atomic weight, the 8 elements starting from a given one will show resemblance in physical and chemical properties with the first element. After this law of octaves, the Mendeleev, and that is Dmitri Mendeleev in 1869 proposed his famous periodic law. And according to Mendeleev periodic laws, the properties, that is physical and chemical properties of the elements, are a periodic function of their atomic weight. So, this is the periodic law of Mendeleev's. It is very important, and from these periodic laws, Mendeleev also formed a periodic table, and this periodic table, that is the periodic table of Mendeleev's, have 9 group and 7 periods. There are so many merits of Mendeleev periodic table. The first one is systematic classification of elements. Number 2 is correction of doubtful atomic masses, atomic weight of some elements, as for example atomic weight of beryllium was corrected. And the last merits is prediction of missing elements. It is very important, prediction of missing elements. According to Mendeleev periodic table and its modified form, at first Mendeleev's original periodic table contained about 65 elements known at that time, there were 7 periods and 8 groups in the original periodic table of Mendeleev's. Noble gases were not known at that time. So there was no groups of noble gases in Mendeleev's original periodic table. As more and more new elements were discovered, it was realized to modify Mendeleev's original periodic table. In this modified periodic table, there are 7 periods and 9 groups. Periods, what do you mean by periods? The horizontal rows of elements are called periods. And what do you mean by groups? The vertical columns of elements are called groups. The modified version of Mendeleev periodic table has 7 periods and 9 groups. The long form of periodic table, that is afterward it is discovered, that is long form of periodic table, it consists 7 periods and 18 groups. What is periodicity? Elements, when arranged in increasing order of atomic number, showed similarity in properties after regular interval is termed as periodicity in properties. In a modified periodic table, where 7 periods and 9 groups, the periods having number 1 period having 2 elements, and it is known as very short period. Period number 2, there are number of elements is 8 and it is called first short period. Period number 3, there is number of elements is 8 which is called second short period. In this way, period 4 having 18 elements is known as first long period. Period 5, where the number of elements is 18, it is known as second long period. And period 6 having 32 elements, it is called very long period. And the last period, actually it is incomplete period. The newly discovered elements are placed here. So it is the number of elements is rest of the elements and it is incomplete. What is the reason for periodicity? It is due to recurrence of similar electronic configuration of the element. As for example, lithium, sodium, potassium, rubidium have same electronic configuration, and for that reason the periodicity appears. Elements of different groups are given some special name depending on their properties. For example, group 1 elements is known as alkali metal. As for example, lithium, sodium, potassium, rubidium. Group 2 elements is known as alkaline earth metal. As for example, beryllium, magnesium, calcium, strontium and barium. Group 11 is known as coinage metals. As for example, copper, silver, gold. Group 15 is known as pnictogens. As for example, nitrogen, phosphorus, arsenic, antimony, bismuth. And group 16 is known as chalcogen. Example is oxygen, sulfur, selenium and tellurium. Group 17 is known as halogens. As for example, fluorine, chlorine, bromine, iodine. And the last group 18, is known as noble gas, and the example of noble gas or inert gas is known as helium, neon, argon, krypton, xenon, etc. And transition elements, actually these transition elements belongs to group 3, from group 3 to group 12, and the example is scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, and so many transition elements are there. Each groups contain 10 number of transition element. Okay, the next is lanthanides. There are 14 elements with atomic number 58 to 71, that is from cerium to lutetium, is known as lanthanides or rare earth elements occurring after lanthanum 57. And these elements, group of elements, that is from 58 to 71, is known as lanthanides. It starts from cerium and completed to lutetium 71. And after that, actinides. Which are actinides? The elements after actinium 89 Se are called actinides, as for example thorium, palladium, uranium, etc. Transuranics or transuranic elements. The elements with atomic number from 93 onwards have been prepared by artificial means and all of them are radioactive. These elements are called transuranics or transuranic elements. The example is neptunium, lawrencium, etc. Now we discuss about the demerits of Mendeleev periodic tables. There are so many limitations, actually 7 points. I discuss one by one the demerits. The first one is anomalous position of hydrogen. Hydrogen resembles both the alkali metal 1A and the halogen 7B in properties. Thus, the position of hydrogen is still a matter of dispute. Number 2, like elements were placed in different groups. There are some pairs of elements like platinum and gold and copper and mercury, which have similar properties with each other, have been placed in different groups. Platinum 8, whereas gold is placed 1B. Copper 1B, whereas mercury 2B. Number 3, unlike elements were placed in same groups. Copper, silver and gold were placed in group 1A along with sodium, potassium, rubidium, etc., though they differ in their properties. Number 4, position of lanthanides and actinides. All the lanthanides have different atomic weights, but Mendeleev put all these elements in one single position. Similarly, all the actinides are placed in one single position. Discrepancy in periodicity. Mendeleev's periodic table contains 4 pairs of elements in which the element with lower atomic weight has been placed after the element with higher atomic weight. This is against Mendeleev's periodic law. These pairs are Ar, argon 39.94 is placed before potassium, where potassium having atomic weight 39.1. Similarly, cobalt is 58.94, whereas nickel is 58.69. Tellurium 127.6, whereas iodine is 126.9. And the last pair is thorium 232.12 and palladium is 231. The next demerit is position of isotopes. As atomic weights of isotopes differ, they should have been placed in different positions in Mendeleev's periodic table, but there were no such places for isotopes in Mendeleev periodic table. And the last demerits is 3 elements in a single position. In group 8, iron, cobalt and nickel have been placed together in period number 4. There is no justification for this. Now we discuss about the position of hydrogen in Mendeleev periodic tables. Actually, position of hydrogen in Mendeleev's periodic table is controversial, and the explanation is hydrogen resembles both the alkali metal 1A and the halogen 7B in property. Justification of placing hydrogen in group 1A. Like alkali metal elements, hydrogen contains one electron in the outermost shell and exhibit a valency 1. It forms hydrogen plus ion like lithium plus, sodium plus, potassium plus, etc. The number 2 is hydrogen forms stable oxide like H2O. Like lithium, sodium, lithium is formed stable oxide, lithium oxide, and sodium is formed sodium oxide. Both are stable. And the last justification for placing in group 1A is like alkali metal, hydrogen is a reducing agent. Now we discuss about the justification of placing hydrogen in group 7B, that is in the group of halogens. Hydrogen forms hydride ion, H negative ion, like halides ion, fluorine, chlorine, bromine, iodine, that is fluoride, chloride, bromide, iodide. To give hydrides, lithium hydride, sodium hydride, like halides, lithium chloride, sodium chloride. Like halogens, hydrogen is a non-metallic diatomic gaseous molecule. Hydrogen is like F2, Cl2, Br2, etc. Metallic hydrides are ionic compound like metal halides. To avoid this controversy, hydrogen is placed separately in the modern periodic table. For this reason, Mendeleev named hydrogen as a rogue element. Now I discuss about the modern periodic laws that is proposed by Moseley in 1911. The properties of elements, that is physical and chemical properties of elements, are a periodic function of their atomic number. On the basis of modern periodic law, long form of periodic table is proposed and it consists 7 periods and 18 groups. In this modern periodic table, the elements on the left side of the periodic table are metals and those on the right side are non-metals, and metal and non-metal are separated by metalloids whose properties are intermediate between those of metal and non-metals. Why halogens are named so? Halogen. Actually, the term halogen means sea salt producer. As these elements are abundantly found in sea salt, as for example sodium chloride, they are called halogen. Now I discuss about some very interesting and special points of periodic table, that is Mendeleev as well as Moseley's periodic table or long form of periodic table. Mendeleev arranged the elements in increasing order of atomic weight. Noble gases were not known at that time, so there was no group of noble gases in Mendeleev's original periodic table. There are some elements named by Mendeleev. Afterward, these elements are discovered, like Eka aluminium, and its original name is gallium. Eka boron, the original name is scandium. Eka silicon, the original name is germanium, and Eka magnesium, the original name is technetium. Francium is an alkali metal which is radioactive. Radium Ra88 is the heaviest alkaline earth metal. Beryllium Be is the lightest alkaline earth metal. Astatine 8085 is the radioactive halogen. Fluorine F9 is the lightest halogen. Fluorine F9 is the lightest halogen. Iodine shows reducing properties, whereas the other halogens are not reducing, oxidizing elements. Group 7b or 17, actually it is in Mendeleev periodic table and it is long form of periodic table, contains element of three states: solid, liquid, gaseous. As for example, solid is the iodine, liquid is bromine, and gaseous is fluorine and chlorine. And xenon Xe is the most reactive among all the inert gas. Actually inert gas are non-reactive, but among this inert gas xenon is reactive. And the last one is radon, which is radioactive noble gas. Now we discuss about the periodicity of properties of elements along the period and along the groups. First properties is atomic radii. Variation in a period. On moving from left to right in a period of the periodic table, the atomic radius of elements decreases. Whereas the variation in a group, on moving down in a group of the periodic table, the atomic radius of elements increases. Number 2 is ionization energy. Variation in a period, on moving from left to right in a periods of the periodic table, the ionization energy of element increases. Variation in a group, on moving down in a group of the periodic table, the ionization energy generally decreases. And the next property is electronegativity. It varies variation in a period. On moving from left to right in a period of the periodic table, the electronegativity of elements increases. Variation in a group, on moving down in a group of the periodic table, the electronegativity of the elements generally decreases. Now we discuss about the properties oxidizing or reducing property. Variation in a period, on moving from left to right in a period, the radii of the atoms decreases with a consequent increase of electronegativity. Hence oxidizing power or property of the elements increases and reducing powers decreases. And the variation in a group, on moving down in a group of the periodic table, the size of the atoms, that is radii, increases and hence their ionization energy decreases. As a result, the reducing power of the elements increases while oxidizing power decreases. Now we discuss about the metallic and non-metallic characters. Variation in a period, on moving from left to right in a period of the periodic table, metallic character of elements decreases as shown in table. Period 3 nature. Period 3 having sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine. First one is metal, magnesium also metal, aluminum also metal, but silicon is metalloid. That is silicon having both the property of metal and non-metal. Phosphorus is non-metal, sulfur is non-metal, and the non-metallic character is highest in chlorine. So metallic character is decreases and non-metallic character increases. Now we discuss about the variation in a group. On moving down in a group of the periodic table, the metallic characters of elements increases as shown in table. Group 14, carbon, silicon, germanium, tin and lead. Nature is, the first one is non-metal, silicon is metalloid, germanium is metalloid, tin is metal and lead also metal. So metallic property is increases when we moving down in a group. Now we discuss about the nature of oxides. Variation in a period. On moving from left to right in a period of the periodic table, the basic nature of the oxide decreases, whereas acidic nature increases. Variation in a group. On moving down in a group of the periodic table, the basic nature of the oxide increases as the metallic character increases, while the acidic nature decreases. Now we discuss about the valency. Actually, valency, there are two scales according to hydrogen scale, and another scale is the oxygen scale. First, I discuss in hydrogen scale. On moving from left to right in a period of the periodic table, the valency of the elements at first increases and become 4, and after that it decreases to 1 as shown in table in hydrogen scale. Period 3, the elements are sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, and the hydrides are sodium hydride, magnesium hydride, aluminum hydride, silicon hydride, that is SiH4, its name is silane, and the next one phosphorus, it is named as phosphine gas, it is hydrogen sulfide gas, and it is hydrogen chloride gas. The valency of the elements, that is sodium, is 1, as because its reactor is only 1 atom of hydrogen. Magnesium is 2, the valency of magnesium is 2, aluminum is 3, silicon is 4, phosphorus again is 3, as because it combined with 3 hydrogen atom. Sulfur is 2, as because it combined with 2 hydrogen atom, and the last one chlorine is 1, as because it is combined with 1 hydrogen atom. So the valency trend is, at first it is increases from 1 to 4, and after that it will decreases and become 1. Now I discuss the valency according to oxygen scale. On moving from left to right in a period of the periodic table, the valency of the element increases in oxygen scale, and it becomes 7 in group 7 elements as shown in table. Here the period is 3, and the elements are sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, and if they form the oxide, then the valency of the elements like sodium is 1, magnesium is 2, aluminum is 3 in Al2O3. In silicon dioxide, the valency of silicon is 4. In phosphorus pentoxide, the valency of phosphorus is 5. In sulfur trioxide, the valency of sulfur is 6, and in Cl2O7, the valency of chlorine is 7. So on moving down in a group of the periodic table, the valency is unchanged or unaltered, whatever it may be the scale, because the elements in the same group having same valencies. Now we discuss about the special properties which I earlier discussed in my classes, like atomic radius. What do you mean by atomic radius? What do you mean by ionic radii? What do you mean by ionization energy or ionization potential? What do you mean by electronegativity and electron affinity? So at first, atomic radius or radii. Atomic radius is the distance between the center of nucleus and the outermost shell of an isolated atom. What is the ionic radii? Ionic radii refers to the radii of the ions in their ionic crystals. What is ionization energy? Ionization energy of an element is defined as the amount of energy necessary to remove the outermost shell electron. Electronegativity means the tendency of an atom to attract electron towards itself when it is combined in a compound is known as electronegativity. And the last one is electron affinity. The energy released when an isolated gaseous atom in the ground state accepts an electron in its outermost orbit to form a mononegative ion is called electron affinity. Actually, ionization energy and electron affinity of an element are same. The only difference is that in the first case, that is in ionization energy absorbed, while in the second case, in case of electron affinity, the energy is released. So both are same but negative. Now I discuss about the limitation of long form of periodic table. There are three limitations. The long form of periodic table has few limitations or three limitations which are discussed below. The position of hydrogen is still controversial. That is, in long form of periodic table, here also the position is not correct, it is controversial. The second limitation is, depending on electronic configuration, helium should have been placed in group 2, but it is placed in group 18 with other noble gases. And the last one, the lanthanides and actinides are placed separately in two different rows below the main periodic table. The elements could not be placed in individual group in the periodic table. So these three are the limitation of long form of periodic table. So we have finished our chapter periodic table. If you have any doubt or you face any problem while going through my video, then please let me know, write in the comment box. Hope you like it.